Hello everyone, welcome back to the continuation of part 1 on spirally printing a matrix. In this particular video, we are going to implement the algorithm discussed in part 1. So if you haven't watched the part 1 video, please check it out because it's going to help you clear out the algorithm for this problem. Now sorry for the delay for this problem because I was sick on Friday and it took me 3 days to recover, and now here I am. Now without wasting any further time, let's get started. Alright, so let's dive right into solving this problem using C++. So I'm going to solve this problem on LeetCode because it has some test cases as well, so that we can evaluate our solution. Right. So let's just quickly take a look at the problem. Yeah. So we are given a matrix. That's all we have, right? So as let's just find out the rows and columns, right? So int rows is matrix dot size, right? And then we have int columns, which will become matrix 0 dot size, right? What else? Then we have our top equal to 0, right? Left is equal to 0. We have now the rightmost would be the number of columns, which would be columns minus 1 basically, and the bottom would be number of rows minus 1, right? Now let's let's do one thing. Let's first travel from, in the topmost row, let's travel from left to right, right? So let's just do one thing. We are gonna let's just skip everything. Let's just continue with this. So we'll say in the top row, I'm going to go from for int I equal to left, I less than equal to right, I plus plus, right? And then I'm going to make a, since we have to return a vector of integers, I'm going to vector of int result, right? And then let's is the font, do I need to make the font little, it's already 16. All right. Okay. So for int I equal to left, I less than equal to right, we then do result dot pushback matrix of, so the row is fixed, it's top, and the column is changing, so I. Then we do we're done with the top row, so we do top plus plus. Now we go for the rightmost column. So for int I equal, we go from top to bottom, I less than equal to bottom, I plus plus, result dot push back matrix of, now the row is changing and the column is constant, so row is I and column is right. So we're done with the rightmost row column, so we come towards our left, so right minus minus. Now we are going to go from right to left in the bottommost row. For it I equal to right, I greater than equal to left, I minus minus, result dot push back. Now columns are changing and row is constant, so matrix bottom row, and we are going from right to left, so right to left, then I, right? And then we're done with the bottom row, so we gonna do bottom minus minus, we are moving up top from the bottom, and then we're going to do last step from bottom to top in the leftmost column, right? So for int I equal to bottom, I greater than equal to top, I minus minus, result dot push back matrix of our, now here our column is constant and rows are changing, right? So rows would be I and column is left, then we do left plus plus, right? So one spiral is complete, right? Now we have to do this process repeatedly. So while left less than equal to right, and then top less than equal to bottom. Let's run this, right? Should work. Okay, I'll just put entire code inside this while loop. Okay, left is this, there's some, okay, I think there's a bracket or something missing. Wait, what I'm gonna do is I'm gonna remove this. I'm gonna just put while top less than equal to bottom, and then left less than equal to right, one bracket here and one bracket here. All right, so just quickly indenting this. Okay, yeah, so there we have it. Now let's give it a run and let's see. We did not return the result, right? So we should return return result. So it's accepted. Let's submit it. We have a wrong answer. Why do we have a wrong answer? Well, let's see that in the next section. We're going to understand why we are getting this wrong answer. Everything looks fine to me. Why are we getting a wrong answer? Let's check. We're going to check it with the particular test case given to us, right? So let's check it out. So let's understand why we had a wrong answer. So this was a test case given to us, a non-square matrix. So after the first, like in the beginning, we'll have these as our starting points. Top would be at 0, left would be at 0. Sorry about that. Right would be at 3 and bottom would be at 2. These are the indices 0, 1, 2, 3 and 0, 1, 2. Now, after the first spiral that we print, the outer spiral, the updated values of top would be at 1, bottom would also be at 1, right would come at 2 and left would come at 1, right? This now let's continue our logic. So we had while loop, while top less than equal to bottom and left less than equal to right, run in all those four directions, right? So this is true. So we'll follow our loop. So first one was from left to right, and after that as a consequence we did top plus plus, right? So we'll do from left to right, we'll go, and left is 1, right is 2, so we'll print 6, right? Then we'll print 7, right? So this is done, and then top plus plus, so now top becomes 2, top becomes 2. So the next loop was to go from top to bottom, and as a consequence reduce 1 from right, do right minus minus. So we go from top to bottom. Our top is at 2 right now and bottom is at 1, so this loop does not run, but right minus minus happens. So right minus minus would be right would become 1, so right becomes 1. So last the next loop was to go from right to left, and as a consequence move up that row, right? So bottom minus minus, so right to left, so right is 1, left is 1, so right, so it will print 6 again, right? And that was the reason of our wrong answer, because the answer was finished when it printed 6 to 7, but we printed 6 again because of this loop. So how can we check that? I mean, one loop over here on the top which checks this condition before running these 4 directions is not enough. So in this next section, we are going to see what changes we can make to the program to make it run using these constraints. So the problem we are facing is that this topmost while loop is not able to check for the conditions after every one row or one column of the spiral. So we need to add logic to check for the bounds after every iteration, right? So I'm going to introduce a concept of direction here. So what I'm going to do is I'm going to say in direction is 0. So what I'm going to do is my 0 direction, the value of direction is 0 equals means that I'm going from left to right. Direction equals 1 means that I'm going from top to bottom. Direction equals to 2 means I'm going from right to left. And direction equal to 3 means I'm going from bottom to top. But at one point I do only this and then I increment my direction. so that at one time I do only this, right? So you'll get more idea when we implement it. So let's just check. I'll say in direction equal to 0. Now if I'll say if my direction is 0, then I'm gonna do this. Wait. Alright. So I'm gonna say if direction equal to 0, then I'm gonna go from left to right, right? If my direction is 1, why does it not auto format? Alright, so if direction is 1, we go from top to bottom in the rightmost column, right? Now if direction becomes 2, as said, you're going to go in from right to left in the bottommost row, right? And then the last, but definitely not the least, which is the usual dialogue, everyone says that. So 3 we have going from bottom to top in the leftmost column. All right, so here we have. So now in one particular after a particular increment, we also change our direction, right? So we're gonna simulate that by saying direction plus plus. So we change our direction, and after we have done it 4 times, we do modulo 4, or I'll better write it like this: direction equal to direction modulo 4. So the cycle repeats 0 1 2 3 0 1 2 3, right? Remainder. Like now let's just quickly just go through it. So what happens is initially the direction is 0, I go from left to right and then increment my top. Now these conditions will not run and my direction will increase, direction plus plus, right? And direction becomes 1, mod 4 is 1. We go into this condition now. So what's happening is our bounds are also changing and they are being re-evaluated every time, because every time I reach this statement, my while condition is evaluated, right? So that's how we are doing it here. So now let's just run it and see if we are able to fix our issue. Accepted. Let's just submit it and hope that we did it right. We have it accepted. Well, that was it for this video. I hope you guys enjoyed watching this video. If you did, please give this video a thumbs up and please subscribe to the channel if you haven't already. And as I told before, 70% of you watch my videos without subscribing to my channel. So it'll be highly motivating for me if you please press that red subscribe button. And that was all for today. I'll catch you guys in the next video. Until then, take care. Bye-bye.